Hello and welcome to the latest episode of Last Week in AI. We can hear us chat about what's going on with AI. As usual, in this episode, we will summarize and discuss some of last week's most interesting AI news. You can also check out our Last Week in AI newsletter at lastweekin.ai for articles we did not cover in this episode. I'm one of your hosts, Andrei Kurenkov. I finished my PhD at Stanford last year, and I now work at a generative AI startup.
And I'm your other host, Jeremy Harris. I am the co-founder of Gladstone AI, which is an AI national security company. We did the rounds, I guess, in the media recently, and that's been fun dealing with all the fallout of that. By the way, I think we were talking about this. I'm not sure if we'll actually do it this episode, but with Udio that just came out, we were talking about using a song that we generated in Udio as the podcast intro song. So you may have just heard that for the first time, which is kind of cool.
That's right. You may have. We'll see when I edit it. I will probably do it, and that'll be quite fun. So yeah, a good example of how these kinds of things are actually going to be useful for people, I guess, right?
I was, so impressed with all those tracks. Like, I don't know, I've spent an ungodly amount of time playing with it and should have been working, but yeah, it's amazing. And then another weird piece of personal-ish news. So I was in New York City the last couple of days. For the first time, I ran into John freaking Crone from the Super Data Science podcast that we've been plugging for the last little bit, and Sadie St. Lawrence, who is she does the Data Bytes podcast. She's the founder of Women in Data. And I've known the two of them for a long time. John Crone, especially, we're big fans of John. We call ourselves his cronies. Anyway, so friend of the show, John Crone, and he's taller than I expected. He said that I was, and this is interesting, he said I was taller than he expected. And the difference is, I thought he was like, at least like 6'1", it's like 6'2", small difference. But he looked at me like, I thought you were like, it was like much, I thought you were much shorter. So I wondered, like, am I giving off short guy energy? I don't know what this is. Maybe Andre, if you at some point want to guess my height, that would be great. And I'm sure the listeners would appreciate it. But we can get on with the show. That's it for my personal update.
That's right. Let's get on with the show. Just one quick disclaimer. We did miss last week. Just scheduling stuff wound up not working out. But we are back. This episode, we're going to cover some of the news we missed last week and a lot of the exciting news that's been going on this past week. There's a lot of stuff. So let us go ahead and just dive in. Starting with the tools and apps section. And of course, we have to start with the big news here, which is, as Jeremy mentioned briefly, Udio. So there's been a lot of excitement in the music generation space. We covered Suno and how they generate really, really high quality, almost indistinguishable from real songs. And now there's a new entrant in that space called Udio that was founded just in December by four former employees of DeepMind. And they just came out with the model. We just got some samples of the songs they produce, and they are really good. It's again, really hard to catch any sort of AI weirdness in the tracks. They just sound really good. You can start with 30 seconds and then extend them. So they produce, about 2-minute songs roughly. And there are a lot of backers for this one, some heavyweight investors, A16Z, and also some notable people in the music space like Common and will.i.am and other investors. So very much a big deal in the music generation space with this new competitor.
Yeah, and apparently, so they've raised, and this is going back to just a couple of days ago, apparently raised $10 million. So that, seems small, but I guess that's pre-launch. The product is super impressive. The one thing is, God, we get so spoiled so fast. I'm generating like incredible quality music, like jazzy beats, whatever, with lyrics too, right? That are really impressive. That's one of the wild things about this is you get lyrics that almost always make sense. You get some weird aberrations, and I ran into a couple where it sounds like the lyrics are saying nonsense, and maybe you hear people in the background, and kind of maybe gets stuck in a local gutter or something. But really, really impressive. it takes maybe about, in my experience, about 5 minutes to actually generate the 30 seconds of audio. And insanely, my brain got so hedonistically adapted to like, I can do this music generation now. And my immediate next response is like, wait, why is it so slow? Like literally like easy, bro. Like 20 seconds ago, you couldn't do this. Let's just give it a sec. So it's just wild how quickly we adapt. But yeah, super impressive product. This is probably going to be a game changer for a lot of different things. It's so hard to think of all the things, but just the ability to make, catchy beats that help you maybe memorize things for educational purposes. This is one application I saw flagged on Twitter. A lot of people talking about the sort of marketing commercial applications and stuff, but definitely valid to call this a ChatGPT moment, I think, for music generation.
Yeah, and the competition now, I mean, generally people say the quality is similar between Suno and Udio. Udio, you could say maybe even is a little cleaner. So there's now, two big competitors there, and Udio is trying to distinguish itself a little bit by saying they're aiming more to cater to musicians. So they have this ability to kind of control a little bit more what the generation is like, tweak it, and so on. The article here in Rolling Stones also mentioned that they were able to, or they found some examples of songs with vocals that sounded a lot like the vocalist Tom Petty. So there is, I guess it is worth flagging that it seems very likely that both Udio and Suno are training on copyrighted data, which is a bit of a gray area for sure, and something that some people, as we'll get to, are unhappy about. But that's just how, I guess, it is right now. They are hitting the ground running, getting these models trained, and the results are pretty mind-blowing right now.
Yeah. I'm also really curious about just like the business model and how sustainable it ends up being. Again, we've seen so many companies like this get gobbled up at scale. The next beat, right? What can GPT-5 do? What can GPT-6 do? Did they eventually just end up being able to do these things trivially? And the foundation, kind of the most general purpose foundation model, eats the rest of the world. Interesting question. Let's see how it plays out, Cotton.
Yep. And next up, the next story is Anthropic launches external tool use for Claude AI, enabling stock ticker integrations and more. So Anthropic has launched the beta of this tool use functionality, allowing Claude to use third-party features, basically API. Users can insert simple code snippets in the API interface, and then Claude will just go ahead and use it. This is something that, of course, has been around for a while, and stuff like ChatGPT. So, this is another rollout of features for Claude that makes it more competitive. Apparently, all Claude AI models can handle choosing from over 250 tools with pretty strong accuracy. So, Claude really, based on its performance and cost, is, I think, starting to be a pretty strong competitor to OpenAI.
Yeah, and when you talk about agent-like models, agency, that sort of thing, the things that are preventing us from getting, to AGI or something like it through agents, it part of it goes through this ability to choose tools and then use those tools really accurately. This article cites the over 90% accuracy in choosing tools from like a list of 250 tools that Anthropic has. 90% sounds really high if you have to chain the use of many tools in a row, and then you have to actually use those tools correctly. You not only have to select them correctly, you have to call them with the right sort of API and the right arguments. That could really quickly eat away at the overall successful percentage completion of a long series of tasks or complex tasks. So I think that's actually something that is going to have to change over time. It's clearly improved a lot. Claude 3 is really, really good at this. GPT-4 has just gotten a little bit better at this. We might talk about that later today, but this is, I think, a key metric if you're interested in tracking progress towards AGI, is like the successful completion of tool selection and then tool use, because you chain those things together in a coherent way, you get to much more general purpose capabilities. And another thing to flag too is just to be specific about what's going on here. we are no longer just relying on web lookup, which is what Claude 3 would previously have had to resort to if you needed to find out something about, I don't know, stock prices or something like that, right? So now there's a dedicated tool for that. So you have ground truth. The error that comes from the web lookup stage is now hopefully no longer present. You're relying instead on a firm tool whose accuracy can be verified, as they put it here, at the source level. So better for sort of the verifiability, the accuracy of these models, and then they have shown themselves to be capable of actually using these tools, selecting these tools properly. So interesting next step here.
And just want to flag this so that the article doesn't quite mislead. There is a legacy tool use format that has been in Claude. So that is not optimized for Claude 3 and is kind of, I guess, less API friendly. You have to provide the tool definition in the prompt. Here, they added it as something as a separate input. When you make an API call, you can specify the tools as one of the inputs, not in the plain text. So not entirely accurate that this is the first time this is coming to Claude, but they definitely expanded how it's used and made it a little more, I guess, cleanly formatted. And interestingly, I've been testing Claude a bit more, and their API has evolved a lot since last year and has become a lot closer to OpenAI's. So again, it seems like they're really coming out of just testing and towards trying to get people to adopt and use Claude. And onto the lightning round with some quicker stories. The first one is building LLMs for code repair from Replit. And this is covering how they are integrating AI tools specifically for code repair. So basically fixing bugs. Apparently, it's using a mixture of source code and natural language stuff. And the company, this tool will aim to, pretty much fix issues that come up in your code.
Yeah, this is coming from Replit, of course. We've covered them a lot on the company. Their CEO, Amjad Masad, is actually, so Y Combinator company. He's really famous in the YC ecosystem just because Replit is such a kick-ass company in terms of its growth. I think Paul Graham himself is like personally invested in them. This is also partly a play for AGI. Like he's kind of indicated his interest in turning this into a bit of an AGI play. And so what they're doing here is leveraging a kind of data that they have that few other people have. And they essentially have these long kind of histories. They don't just have the code bases of the people who develop on their platform. They also have like the history of the edits that have been made to that script, and so they're leveraging that in their training process. It's built off, this model is built off DeepSeek Coder, which is sort of like open source instruction tuned model that has been really effective in the past, specifically for code. So this is an open source thing in a sense, and they are being quite open about the technique that they've used to fine tune it. They used 8 H100 GPUs. They tell you all the kind of number of shots that they use in their training process. It's actually like fairly open, and it reflects their interest in the open source movement more broadly. So yep, definitely an interesting result, and we'll have to keep track of Replit as well and see if they keep moving more and more towards the center of this sort of like middle range, middle tier companies in terms of AI. Think here of like Meta arguably leaving that pack, but certainly companies like Mistral and Cohere, where it's like they're building impressive models, maybe not on the frontier, but definitely contributing to open source in important ways.
Next up, early reviews of the Humane AI pin aren't impressed. So we've covered the Humane AI pin, which is this little wearable kind of square thing that you can talk to. It also has a projector and a camera and costs $700. So the idea here is like a new type of hardware that is AI first and can in some ways replace your phone. Yeah, you can tell it, to do stuff, and it will use AI to intelligently do it. It has released, it started being sent out, and people started reviewing it. And the consensus, at least according to this article, is that it is maybe could use some more work. It seems like it's often slow to respond. It is a little bit buggy, so sometimes it seems to do the wrong thing. If you tell it to play a song, it may instead talk to you about its instructions regarding that. If you ask it for the weather, it could take 10 seconds to reply, things like that. So in general, it seems like maybe not too surprising given that this is the first generation and it's just rolled out. Of course, the company is saying that there's a lot of updates slated to improve, but I guess worth highlighting because there is some excitement around these AI-driven devices as a new category of hardware.
Yeah, we've seen the Rabbit R1. We know OpenAI is working on potentially their own thing with the Johnny Ive project. So yeah, not the another entry, let's say, in that long list or growing list of hardware projects. I'm curious if this ends up taking off. It's a weird form factor. It's not what I would have expected. Apparently, if you ever watch Star Trek, you're meant to tap it like a communicator badge, that they have on their chests. Basically, you hit a button and then you ask it whatever. It's a little bit, I don't know, it's a little bit unusual. It doesn't strike me as the kind of thing that I would design, but hey, that's why I'm not getting paid billions of dollars to do this. So
next up, Microsoft's 365 Copilot gets a GPT-4 Turbo upgrade and improved image generation, and that is pretty much the story. Microsoft now has priority access to GPT-4 Turbo for business subscribers.
For sure, and maybe buried in this lead, or the buried lead here, is that GPT-4 Turbo is now out, right? OpenAI has put that out there. It's got a lot of features that are similar to the old GPT-4 or the kind of prior version. It's got a 128,000 token context window, so that hasn't grown, but it does have a more up-to-date knowledge cutoff. So December 2023, as opposed to April of last year, which was the previous knowledge cutoff. So that's helpful. It's also been reported to have, OpenAI claimed that it has way, way better reasoning capabilities. It's been reported to have somewhat better reasoning capabilities on simple problems. On complex problems, more advanced problems, that's where it shines, it seems. And there have been people who've kind of suggested, hey, maybe there's a little bit of metric hacking here where OpenAI is getting really used to the benchmarks that they're trying to hit and maybe over-focusing to some degree. Some people suggested that on those benchmarks. And so you don't, as an everyday user, tend to see the value as much. I don't know that that's necessarily the case. It seems to me that the focus here really is on that more advanced reasoning. And so for most practical use cases, you're not going to be leaning on those abilities. Maybe that's why a lot of people just haven't seen it materialize in their kind of experiments with it. But on a benchmark basis, it does do better. And it's what OpenAI needed, right, to climb ahead on all those leaderboards. Claude 3 Opus came out, Google's Gemini nipping at its heels, right? So they had to find a way to get back on top. Make no mistake, though, this is not the latest and greatest model that OpenAI has, right? They internally absolutely are going to have more advanced models that they are not yet releasing, that they're testing, refining, and so on. But if you think about what the situation looks like for OpenAI, they're sitting back, waiting for the next model to kind of beat them on the leaderboard, and then saying, "All right, let's just get reclaim that number one spot." That at least seems like it could very well be the play here, but hard to be 100% sure. That's at least my suspicion at this point.
And one last story for the section. AI editing tools are coming to all Google Photos users. And that's pretty much the extent of it. These features such as Magic Eraser, Photo on Blur, and Portrait Light that used to require a subscription to Google One, now it will be coming to all Android users and extending to more devices. So I think interesting to highlight just because this is now one of the ways to compete in the smartphone space to provide AI features. And more phones are starting to get, especially for photo editing, things that are AI powered. And on to applications and business. Starting with, Google announces the Cloud TPU V5P, its most powerful AI accelerator yet. So the TPU, the Tensor Processing Unit, has been something that Google has worked on since 2016. And as the title says, they are now on V5, which consists of 8,960 chips and now has the fastest interconnect yet at 4,800 gigabits per second. So lots of claims here saying that these are faster than the version 4 TPUs, featuring apparently a 2x improvements in flops and 3x improvement in high bandwidth memory. So yeah, pretty clear that they are pushing forward in this front. They do say that apparently Google DeepMind and Google Research users have observed this 2x speed up on large language model training workloads, which is, of course, pretty significant because a lot of that is presumably happening at DeepMind.
Yeah, and this really is a scaling play, right? So the V5E TPU, and by the way, just as a backgrounder, TPU as opposed to GPU, right? TPU is this kind of like Google only architecture. The GPU is the graphical processing unit. The TPU is the tensor processing unit. It's designed explicitly for AI workloads from the ground up, and it takes advantage of certain certain properties of the kind of like matrix multiplication process that just run a lot faster on their architecture. The previous version, so V5E, the Viper Lite was the kind of code name for it. This new one is the Viperfish. So the distinction between them, in addition to the basic specs of like interconnect and flop performance, is the connectivity and scalability of that connectivity. So, Andre, you talked about this idea that you connect to a pod of basically like almost 9,000 other units. So this is a big difference from the previous version that could connect to 200. Yeah, you could have 256 TPUs connected at a time. This one, you first connect to 64. You can connect up to 64, and then with the rest of a pod of almost 9,000. So it's just got a lot more of an upper bound in terms of what it can accommodate, and that's going to matter way more as Google moves more and more in the direction of super large scale training runs, right? The big differentiator when you look at what Google has done in its latest papers, I mean, they're almost like a hardware, not a hardware company, but like their advances are disproportionately driven by hardware, partly because of Google's outrageous scale. They have way more scale than Microsoft. Easy to forget when we look at OpenAI's progress, which is driven by their access to Microsoft hardware. Google has way more. So when you actually look at like their most recent papers, usually the big breakthroughs have to do with like, oh, we just figured out this new way to connect way more GPUs than ever before. Famously, we talked about this on the podcast, but like connecting GPUs from across different data centers and getting them to do training runs together. So really is kind of a hardware focused effort there. Not that it's not an OpenAI and Microsoft, but Google just does it at a whole other level of scale. So this is a reflection of that focus, and we'll see what kinds of training runs it actually empowers.
That's right. And I think the fact that DeepMind researchers have access to this just kind of made me think of like, they do also benefit from the ability to experiment at scale. So for instance, we've covered recurrent architectures, Griffin, and in these papers, usually they do have, 2 billion parameter, 8 billion parameter models that they present results for. And as we'll get to in a bit, they actually now have released a model based on that research. So having access to this very powerful hardware and being able to run training runs so fast for large language models is a pretty good advantage for their R&D efforts, for sure. And the second main story is also about hardware. I figured we could combine the two. So this one is about Meta, and it has also unveiled a new version of its custom AI chip. This is the Meta Training and Inference Accelerator, or MTIA, and they have now a successor to the first version, which was from last year. And as with the TPU v5, of course, there's a lot of claims here on its performance. So, for instance, they say that it delivers up to 3 times better overall performance compared to MTI AV1. And they say that this is especially good at running models for ranking and recommending display ads on the platforms. Apparently, they're not using this for training yet, and they are just starting to roll it out in 16 of its data center regions. So definitely not as far along as something like the TPU, but it does showcase that Meta is continuing to push in this direction, and I guess also trying to have this edge that Google is, one of the only players that really has that.
Yeah, and Meta kind of playing catch up here on hardware as well as software, right? Like you mentioned the TPU at Google being much more mature. I mean, they've been on this for the better part of a decade now. Microsoft as well has their Athena chip that they're designing. This is basically all a bunch of people saying, hey, whoa, wait a minute, Nvidia, like your profit margins are insane. You're able to charge extortionary prices for your GPUs. That's starting to change, by the way, and for very interesting reasons. But increasingly, there's a desperation to find other choices. And a sense as well, by the way, we talked about this almost a year ago when ChatGPT came out, and we're talking about the margins and like where does the profit end up getting stuffed in the stack, right? What are the actual parts of the generative AI stack that are profitable long term? There's an argument that says it's not actually the model developers, because that ends up being commoditized. Certainly at the open source level, there's so much competition. Like you're not going to make money by making the best open source model for the week, right? The cost of switching between platforms is just so high, and but at the same time, like you can't justify. So you're not going to peel people over due to quality at that stage, and those advantages end up being defensible for such short periods of time. And so a lot of my own personal thesis, and I think this is now bearing out, is the profit is to be made at the hardware level. The big, heavy capital expenditure bottlenecks are in semiconductor fabrication. That's why we talk about that a lot on the show, but also on the design of new generation chips. And that's where Meta is desperately trying to catch up. Again, they're behind Microsoft. They're behind potentially Amazon as well. You look at Gaudi 3 that's coming out too. So a lot of activity in this space, and it's not clear who's going to win. But if you're going to be a hyperscaler in the next 5-10 years, not having a homegrown chip design play is probably not going to be an option. There's just too much profit to be made at that level of the stack. So I think that's really where this is starting to happen. And then we're even seeing some of the chip developers, the fabs, like, for example, Intel, try to venture into the design space as well. So everybody's trying to climb on different levels of the ladder to own more and more of that stack. And I think we end up seeing a lot of fully integrated stacks within the next, couple of years. It's going to take a while for these things to get off the ground. But this play by Meta is just sort of like another one in a long series of FANG companies making the similar bets.
And moving on to lightning round, actually, why not start with that story that you mentioned with Intel? And the story is that it has unveiled its new AI accelerator, the Gaudi 3 chip, which is meant to enhance the performance in training AI system and inference. They say it will be widely available in the third quarter, so it's just the unveiling for now. They claim that it will be faster and more power efficient than the Nvidia H100, saying that apparently it trains certain types of AI models 1.7 times more quickly, and running it inference 1.5 times. So some pretty big claims, with H100 being one of the leading chips that people use, pretty much the leading accelerator so far. Until, of course, the new Nvidia one becomes the main one. So, Intel really coming for Nvidia with this one, and it'll be exciting to see if they are able to compete.
Yeah, and I think this is a good opportunity too to call out and start to like maybe build, some of our listeners' intuition about what matters when you look at hardware and these big announcements that say, oh, well, we've got this thing, it's going to be better than the H100. The big question you always want to ask is, when will the production run actually be scaled, right? When are we going to start to see Gaudi 3 chips coming off the production line in quantities that actually matter? Because remember, a lot of this stuff is bottlenecked by semiconductor fab capacity over TSMC. How much capacity has Intel bought out for that production run? How fast can they get those get the designs kind of finalized, shipped, and then fabbed and packaged and sent back? So right now, the problem that Intel has is by the time the Gaudi 3 comes on the market in a meaningful sense, in large enough quantities to make a difference, Nvidia will already have juiced out the H100. They're already on the H200. The B100 is going to be imminently coming on the market. There's the window for profitability here looks like it actually may be fairly narrow. So even though, it's impressive, Intel, if true, they'll be hitting pretty solid performance relative to the H100. It may not actually matter all that much by the time they can actually get this to market. Still important for Pat Gelsinger, the CEO of Intel, who's betting big on this kind of big hardware play. Really, really important for them to flex those muscles and start getting better at this. So this is a good step forward for them, but they absolutely need to catch up. Gelsinger, by the way, did not give pricing for this new chip. He said it would be very cheap. Right? He said a lot below, were his words, the cost of Nvidia's current and future chips, he claimed. So we'll have to see. He said that they provide a really good, an extremely good, he said, total cost of ownership. This is the total cost of owning the chip over the lifetime, cost of running it, maintaining it, buying it in the first place. That's the thing you really care about, right? What is the total cost of ownership versus how much profit can I make from the chip if it's running, at a reasonable level of use, let's say, over its lifetime. So the claim here is, this is going to be a really dollar efficient option, but we don't know how it'll stack up, not against the H100, but again, the relevant thing at that point may well be the Blackwell line. It may well be something much more powerful. So we'll just have to see.
Next up, Adobe is buying videos for $3 per minute to build AI models. So apparently they're offering $120 to its network of photographers and artists to submit videos of people performing everyday actions or expressing emotions. They're asking for these short clips with people showing emotions and then different anatomy and also interacting with objects. The paper submission on average apparently will work out to $2.62 per minute, but could also be more. So showcasing that Adobe is committed to building an AI video generation model and that they are still committed to their very safe, conservative route, or you could say tactical route, of not leveraging potentially copyrighted data, instead gathering data that they own and can safely train on.
Yeah, it's actually really interesting. They're implicitly placing bets essentially against what OpenAI and other companies are doing, right? To the extent that OpenAI, for example, is just like training straight off of YouTube, which was the allegation that was brought forth. We talked about this on the last episode, I think. If that ends up not being kosher, well, then then the advantage goes to Adobe. But if the opposite is true, then Adobe's kind of wasting its resources here to some degree. Not that this is going to be a huge spend. Interesting that Adobe's doubling down on this. Obviously, they were really, I think, the first company to bring in indemnification offers for their users, right? Saying, we are so sure that you're not going to face copyright issues by using the output of our models because they were generated on our own proprietary content, that we are going to defend you in court if anything happens. So, this is them doubling down, presumably, on that dimension. They're trying to make that their differentiator. I think this is a really good play. I mean, it definitely is a legit differentiator. They forced other companies to try to catch up and do similar things. These kind of pay to play data sets is something we may see more and more of in the future.
And speaking of data and getting access to data, the next story is OpenAI transcribed over 1 million hours of YouTube videos to train GPT-4. So this is reportedly what happened. This was just a bit of info that came out. And headline said it all. Apparently, they had to transcribe a lot of YouTube videos to get a more useful data to train with. And of course, if that is the case, Google stated that it would be against their policies.
Yeah, and we called this out at the time that Whisper came out, this famous speech-to-text model that OpenAI put together. But it was pretty clear at the time that this could well be a strategy to kind of find new sources of data to collect, new sources of text data to collect, basically, as they were starting to run out of the text they could crawl on the internet. It looks like this was kind of legally questionable behavior, but OpenAI's position was that it was fair use. This is all a gray area, so nobody really knows the answers to these thorny legal questions about what is and isn't fair use in this context. Notable, though, that OpenAI President Greg Brockman was personally involved in collecting the videos that were used. So this is very much like, all the way to the top type thing. Now, what was interesting about this, too, is Google was reached out to for a comment on this story. And, OpenAI claims that they respect robots.txt files, which are these kind of subdomains on a website that tell crawlers, like the one that OpenAI presumably or may have been using, that tell those crawlers what they can and can't do on the site. And the Google spokesperson said, well, both our robots.txt files and our terms of service prohibit unauthorized scraping or downloading of YouTube content. And so the implication is, if that's what happened here, like, that is a violation. So anyway, it seems like this may well have been a thing, but Google itself has actually, it's worth noting, trained its models on YouTube content. The spokesperson said this. They said it was in accordance with the terms of their agreement with YouTube creators anyway, which of course makes sense, but still kind of worth noting there's an asymmetry if that's the case in terms of the legal exposure here. Google is able to use YouTube content, OpenAI can't, or may not be able to. They're doing it anyway, but they may or may not be legally allowed to do that. So kind of an interesting way in which the law intersects with AI training runs these days.
Yeah, and it really makes me wonder, like, when will we finally know?
Yeah.
Because it's been going on for a while. We know that image generators, of course, use copyrighted data. And I guess the legal process will drag on for a while with all of these things. But at some point, right, this question will have to be answered of, can you use? Is the fair trade argument legit? We still don't really have an answer.
Yeah, maybe lawyers who listen to the show, I know there are a couple at least, please let us know if you're tracking anything. I know there's one actually who reached out to me. I gotta get back to him actually, but he gave me a rundown on this a couple months ago, and there's some cases that seem like they're starting to kind of create that the precedent that might establish the answers to these questions, but that was a few months ago, so who knows? Kind of interesting to track.
Next, moving away from all that sort of thing, we have a story. Waymo will launch paid robotaxi service in Los Angeles on Wednesday. So that's it. They have been offering free tour rides in Los Angeles over the past year. They received regulatory approval to expand to a paid service just last month, and they are going to start rolling it out. There are over 50,000 people on the waitlist to use the service, and they'll currently just cover a 63 square mile area from Santa Monica to downtown LA. So yeah, exciting to see them starting to expand the paid service to another city. They have primarily been in San Francisco so far, and they are also testing in Phoenix.
Yeah, you can finally go to LA, Andre.
Yeah, because of course I will not go anywhere unless it's in a Waymo.
That's right. Your no human drivers policy is intact.
Couple more quick stories. This next one is OpenAI removes Sam Altman's ownership of its startup fund. We covered this a little while back, that there was reporting of this weird ownership structure where Sam Altman was the owner of the startup fund of OpenAI. Well, I guess after that came to light, they decided to go ahead and change that up, and that is the case. There was a filing with the SEC that it is no longer the case.
Yeah, this is like, if you're thinking, hey, this seems super weird, and you've never heard of a situation where somebody was just like put in charge of an entire fund, and apparently the intent was not for them to just keep it, but like they were just being trusted to hold on to the bag until the situation could be worked out. That is really weird. That's weird. I've never run into anything like this in my whole life in Silicon Valley. I mean, this is highly unusual, but everything about OpenAI is highly unusual, right? They have this weird cap for profit structure, this weird nonprofit board. So, I'm not a lawyer. I'm not sure what might justify this, but part of me is tempted to say, like, this is, it seems like something that maybe should not have been done this way. It's a $175 million fund. So large, but relative to OpenAI's valuation, relative to how much they've raised, relative to how much they make, not actually all that big. But it has been now moved over to Ian Hathaway, who was a partner at the fund since 2021. This is according to that filing. And Sam is no longer going to be a general partner at the fund either. So it seems like I'd be more curious to dive in specifically to understand, what is his exposure to the upside from those investments? Is there any? Like, how does that work? But in any case, at this point, a spokesperson from OpenAI is just saying, like, look, the general partner structure was never supposed to be the way this went long term. It was always a temporary arrangement, and that they hope that, quote, this change provides further clarity, which, as ever, with the intrigue of the OpenAI board, or now the OpenAI fund, it seems like further clarity is the last thing that the resolution seems to bring. I think, I don't know. I kind of feel like for something this important, a bit more clarity would be nice, and it seems like they're not keen to share. So I guess we'll just have to see.
Mm-hmm. And on to projects and open source with the first story coming back to Mistral, one of our favorite releasers of models. And this headline, I guess, is fairly accurate. Mistral AI stuns with surprise launch of new Mixtral 8x22B model. Stuns is a big one, is a big term, but this is a pretty big deal. They have launched this 8x22B, so that's coming up on their previous model, which was, I think, 8x7B. And so this is the biggest model they've released so far. It has 176 billion parameters, context size of 65,000, and it, of course, will outperform the previous 8x7B model, which was already really quite performant, and of course also Llama 2. And in addition, the model has an Apache 2.0 license, so once again, pretty much do whatever you want with it. No restrictions for commercial use, no restrictions at all. And so probably, this just happened, so we don't have too much information, but probably a top of the line open source model at this point, for sure.
Yeah, it's Mistral keeps doing this and coming out with like the next big thing. This is really impressive. One thing to note, I mean, it is a big honking model, right? 22 billion parameters for each expert. There are 8 experts, 176 billion parameters total. This is not the thing that fits on your laptop, right? It's 281 gigabyte file just to download. So you're going to need a lot of horsepower, a lot of actual AI hardware to run this, which, you get the usual round of questions like, what is open source really, right? Again, we talked about this last episode, but like, is there a sense in which if you release a model that is so big that no one can use it without like tens of thousands of dollars of advanced AI hardware, like how should we think about that fitting in the open source ecosystem? I mean, this to me, the real, I don't know, I think it's a little pedantic, but it is being asked. I think the real answer here is like, well, they made the model. What do you want? It's open source. The weights are available. This does have, by the way, a 65,000 token context window. So this is a lot. I mean, you can fit a book in that. That is, I'm trying to think, I think that may be the largest context window available in the open source right now. I can't easily think of another, and it is comparable, or actually outperforms GPT 3.5 on a number of benchmarks. So it's we're barreling towards a world where we have GPT-4 equivalent models out in the open, and where the context windows are getting long enough that you start imagining these things doing some really impressive sort of task chaining. I think that this is probably going to be another big bump for the agent-like models and agent systems, because that task coherence length is indexed to context window size to some degree, and certainly to scale and overall capabilities at reasoning, which this thing very much seems to have. So impressive result. Mistral, as I like to say, they are a French company, is at it again.
Yeah, they come in strong on the leaderboard. I just looked this up out of curiosity on the Hugging Face leaderboard, and they are topping the benchmarks, beating a lot of the other open source models like Qwen and DBRX, Base, Yi, etc. So as before, impressive performant model. And one of the biggest ones, I think Grok is still bigger, if I remember correctly. But
yes.
Yeah,
I think it's 300 some billion, if I recall.
Yes,
yeah,
that's right. Next, some smaller models now coming from Google. So Google has announced some new additions to its Gemma family of lightweight open source AI models. The first one is Code Gemma, which, as per the title, is meant for coding. They trained on 500 billion tokens of English data from web documents and code, and apparently it performs quite well. Doesn't beat the best models out there like DeepSeek Coder, but is quite fast to do inference on and gets pretty good results, pretty good numbers. The more interesting one is recurrent Gemma, which is an efficient model with a recurrent structure. They linked to this paper we discussed a while back of Griffin mixed gated linear recurrences with local attention. And yeah, not too much information on this one. They basically say that it has the nice scaling property of being able to basically scale linearly. So the throughput on different sequences goes down a lot slower than non-recurrent architectures. They do say that it doesn't seem as performant. In the announcement, they don't highlight performance especially. So not too clear, how well it performs, but they are saying that this is released, primarily for research purposes and for people to build upon.
Yeah, and again, that focus on throughput, really, really important on a number of levels. One, of course, it's more of that kind of focus on hardware and like, let's get these systems to be able to use our hardware as efficiently as possible, kind of get those tokens pumped through. Really, really matters in code, especially because when you're talking about agent-like models that can do useful things, very often a coding model is the kind of model you're using for that, right? You want to build apps, you want to do interact with websites in certain ways. So the kind of robustness of the logic, but also the ability to do inference really fast and efficiently by having a lot of throughput, that's going to allow you to do more thinking, if you will, at inference time, which is exactly what agents are all about, right? Agents are just a way to move compute resources from the training phase to the inference to inference time, to reallocate your budget, and often give you a big lift as a result. So getting really good throughput means you can do complex tasks in shorter periods of time, which matters for things like user experience, and experimentation and all that good stuff. So yeah, really interesting. The recurrence play, something that we've definitely seen before. And when you think about state space models like Mamba, like recurrence definitely is philosophically aligned with that. That's very much what those are about. So, all of these ideas seem to be bubbling up more and more to the surface, both in terms of throughput, but also like context window expansion, and indeed all the way to like infinite context windows we may end up talking about. So yeah, a very Google result here.
And just one more story in the section, and this one is pretty different, pretty interesting. It's Aurora-M, the first open source multilingual language model red-teamed according to the US executive order. This is a 15 billion parameters model trained on English, Swedish, Hindi, and so on, trained on over 2 trillion tokens, so pretty significant. Apparently, it started off from Star Coder Plus and then trained on some extra data. And as per the title, I guess the big deal was that it was rigorously evaluated across various tasks and languages. So they say that the model was fine-tuned on human-reviewed safety instruction, and that apparently has aligned it with the red teaming considerations and specific concerns articulated in the Biden-Harris executive order. Not too much, we haven't seen people kind of calling out the idea that their model has been developed in accordance with the executive order. So I guess they're trying to stand out with that pointer. And it'll be interesting to see if others like Anthropic and so on will also start highlighting that capacity of their models.
Yeah, no, you're absolutely right. Like I get some vibes from this that I think they really want us to focus on that U.S. executive order red teaming piece. The model itself, it's nothing to write home about. It's a 15 billion parameter model. Llama 2, which by now is I don't know how many months old, but it's a pretty old model at 13 billion parameters, outperforms this 15 billion parameter model on most benchmarks, right? But of course, that's not what this is about. It's really about that red teaming piece, really about showing that open source models can adhere to this kind of new regulatory framework that's being proposed. So that's kind of interesting. I will say, one notable omission, they do a whole bunch of evaluations for what's known as the CBRN portfolio, chem, bio, radiological, and nuclear risks. So interestingly, they call it the CNBR. They call it CNBR, which I've never seen before, but CBRN is usually what this is called. So they have a bunch of tests there. One thing to flag is you cannot do these tests in the open source thoroughly enough. There are always, like, if you think about the level of access you would need to actually know what the right evaluations even are to run for nuclear risk, for biological weapons risk, this is not the sort of thing that you either can tend to know as an AI developer or certainly open source. And if you did, that would come with its own risks. So there's always this challenge when it comes to evaluating open source models, and this is an open problem. Like, how do you come up with evals that are safe to even publish, right? So like, just as I guess as a baseline background piece of information, these evals are going to be leaky in some sense, still an important contribution. The eval dataset consisted of 5,000 red teaming instructions, 4,000 they pulled from Anthropic, 1,000 they made themselves, and they cover that whole smattering of concerns. But one interesting omission: nothing in these evals about self-replication or self-propagation. Right, this idea that models may be able to replicate themselves or whatever. It's associated usually with the alignment risk scenarios. That, by the way, is in the executive order. So the fact that it's absent here, I thought was actually really interesting. In some sense, this is not a complete test or it's not a complete red teaming according to the executive order. It is missing a fairly significant and important set of components. So not sure why that happened. Self-replication and propagation, much more difficult set of evals to design and execute. So maybe understandable if they want to wait for later or not do it. But I thought that was kind of interesting because it is the sort of thing that we'll have to change over time if we're going to start to full on adhere to these executive orders.
One last interesting thing to mention is that this is coming out from a huge group, a collaboration of people from across 33 different institutions, led by the Tokyo Institute of Technology and by a person at the MIT IBM Watson Lab. So a real mishmash of universities, groups, and so on, I guess, contributing data and contributing to the red teaming. Definitely, as you said, if you look at the paper, it doesn't outperform Llama 2 13B on benchmarks. It's not, the top of the line model as far as open source models go, but still worth appreciating that they put out a paper, they put this out in the open, and they did kind of make a point of saying that they went through this route of red teaming according to the US executive order.
It would be great to see more stuff like this in the future, for sure.
Yeah. And on to the research and advancements section, with the first story being from DeepMind, and I think one of the big ones from last week. It is mixture of depths, dynamically allocating compute and transformer-based language models. So we know about mixture of experts. It's where you have a model that, as it does its forward pass, can essentially pick different branches to go down and say, for this output, I will have these subset of weights be active, and they will produce the output. And this paper extends that in a slightly kind of similar but different direction, where instead they say different inputs can choose to skip layers in the network. So instead of saying, I will go to this branch and not this one, they'll say, I will skip this layer and just use less compute to output. And works fundamentally similar to mixture of experts. They say that you can train a model to select, it ranks which tokens to keep and which tokens to skip. And as with mixture of experts, what you end up with if you use this, especially if you combine it with mixture of experts, is the ability to get the same loss for less cost. So using fewer flops, you can achieve a lower cost. And so this to me seemed pretty exciting given how significant MOE, mixture of experts, has been with things like Mixtral and allegedly GPT-4. Seems like mixture of depths can do that as well, and the two can be combined to have even more benefit.
Yeah, and I think it's probably, again, I mean, you see Google focusing so much on how can we optimize for the use of our hardware, right? That like, and we're not seeing the same publications coming out of OpenAI, probably just because this is being done internally. We don't hear about it, but just the fact that Google has so much hardware means naturally they're going to orient towards this really hard, and it's an interesting result. It's an important one. You know, alternatives to this historically have focused on methods like early exiting. Basically, you think of your input that gets fed to your model, and it goes through layer by layer by layer, and then eventually, for a given token, the model might decide, oh, okay, you know, it's not worth investing more resources into massaging this one further, so I'm just going to route that straight to my output, right? Do early exiting for that token. In this case, it allows you to essentially do, like, instead of early exiting where you have to just decide binary, like either you continue down the rest of the model or to the next layer, or you leave and you can't interact with any of the future layers. This allows you to skip specific layers. And they speculate in the paper that this might actually be very desirable for scaling reasons that they don't go into much detail on. So kind of interesting. They do highlight that they're able to improve by 1.5% on the essentially the log probability of the training objective. So basically let's say the error or the loss function they're using to train the system by using the same number of training flops. So same amount of training compute, and you get a 1.5% improvement in the loss function, which is not necessarily tied in a transparent way to performance, but it's certainly indicative. They're able to train models to parity with other transformers, sort of vanilla transformers, if they use the same amount of training compute as well, in a context where they can save upwards of 50% of their compute at inference during a forward pass. So it makes it a lot cheaper to actually run, not just train. So these are a lot of really interesting advances from DeepMind. Obviously, we saw their heavy-duty mixture of experts paper come out a couple of weeks ago. We covered it, where, you know, the token would be routed to a path. Like, anyway, it was like a more augmented version of mixture of experts. This is instead breaking it down, as you said, Andre, layer by layer, thinking of each layer almost as a kind of a submodel. So they're definitely exploring a lot of acrobatics with their parallelization schemes.
That's right. I will say one thing I found disappointing in the paper is they didn't really compare. They do cite and discuss, you know, related prior work and similar ideas, but there's no comparisons here. They just show results on using this exact technique. So it's a little hard to say if similar ideas have been proposed that also promise things. But of course, the exciting bit also is that they are evaluating this at scale. So they scale up to 3 billion parameters, train models, and do show pretty significant benefits. So, you know, regardless of whether maybe something like this existed or something similar, here we see that, you know, this general idea seems like it potentially could be used together with mixture of experts to keep scaling, which is, of course, probably what people intend to do. And on to the next main paper, this one from Google, not DeepMind, but I guess also Google. The paper is Leave No Context Behind, Efficient Infinite Context Transformers with Infini-attention. And that is the idea, that they propose a way to scale transformer-based LLMs to infinitely long inputs with bounded memory and computation. That is done by incorporating a compressive memory into the standard attention mechanism that includes both local attention over that memory and long-term linear attention. And they compare to some other variants of this. So there was a paper called Alimi Former also from last year. There's variants on this that people have done with KNN lookups and variations. Here they, I guess, are different in that they focus on the compression every time step. And they show, according to their evaluations, that relative to these alternative ways of achieving essentially the same thing, they're able to do better on things like 500K length book summarization. And they evaluate this with 1 billion and 8 billion parameter LLMs. So yeah, another, exciting and potentially useful way to vary the architecture of a transformer coming from Google.
Yeah, I actually thought this scheme was surprisingly simple. And also, I haven't heard people say this, but and maybe it's wrong. I don't like it. It reminds me a lot of a state space model. Like there's a lot here that kind of philosophically is like that. So in a standard vanilla transformer, you take in your inputs. You let's say one input at a time, one sentence at a time, one whatever at a time, and you're going to do the train this thing to do text autocomplete on the sequence that you fed it. Essentially, that's kind of the training process. And okay, that's all there is to it. The model's weights get adjusted as it learns more context from doing that, and then eventually gets good at writing. But each time it looks at an input, it is just looking at that input. It's just looking at whatever the sequence is that's just been fed to it, or as they put it in this paper, the segment that's just been fed to it. In this case, though, it's kind of like if it's reading a long document, it'll read whatever the segment is that it's been fed, and then it proceeds to the next segment. It keeps a compressed representation of all the stuff that's read before. It kind of maintains that in a sort of memory. It's, again, a compressed representation of the keys and queries, if you're familiar with the architecture. And then it combines that with the input from the current segment that it's reading using a vanilla transformer, and glues them together, basically concatenates those two things. So you have the memory piece and you have the immediate segment that you're looking at. And then based on those inputs, you do your final kind of prediction for the next word or whatever it is, the next token, whatever you're predicting. Again, like this strikes me as being very state space model-y. Like you essentially have this explicit memory that's being updated on a regular basis as you move from one segment to the next in the text. And that gets combined with your immediate sort of short-term memory focus, your kind of causal memory focus, if you will, or the thing that you're looking at in the moment. So yeah, I thought this was a really simple idea. It seems to work really well. And no coincidence, I don't think, that this is coming out after Google Gemini, where we're starting to learn about like these infinite context windows. We know Google has a research-only version of a transformer of some kind that can do up to $10 million and in fact more of context window size. So, those two ideas may be related, right? This may be the way that this is done. We talked about another hypothesis that maybe this is ring attention as well in a previous episode. It's a bit unclear which possibilities are being deployed here. But I saw there's a great video by AI Explained who covers this at a high level. He doesn't go into the architecture like we just did, but he highlights that one of the authors of this paper is actually one of the authors of the Gemini paper as well, that came out with a sort of very large context window, which sort of leads one to suspect that this may actually be the thing that's powering those very large context windows. Nothing known for sure, but there it is.
Could definitely be related. And they are, again, it's worth mentioning that this basic kind of idea is not new. So there's papers, for instance, auto compressors and RMT, memorizing transformers, compressive transformer. The idea of compressing what you've computed so far and using it forward down the path is not new. So I think the details are really more in how the compression is done and the kind of specific math behind it. But regardless, it's, again, coming from Google. They evaluate it at scale and they show pretty decent improvements on the prior state of art. So again, another kind of idea worth keeping in mind, this idea of infinite compression and kind of adding recurrence to LLMs, which is not dissimilar from Griffin or Mamba, as you said. Next up, moving on to the lightning round with some faster stories. First one is Octopus v2 on-device language model for super agent. And the gist is that they have a method that enables an on-device model with 2 billion parameters to outperform GPT-4 in terms of accuracy and latency and reduce the context size by 95%. Yeah, it reduces latency latency in particular to levels suitable for deployment across various edge devices in production environments. And it's all about that on-device LLM kind of stuff.
Yeah, and actually, so when what they're doing here that's a little bit different, or one of the key differences is they represent functions that they want this model to call on as their own tokens. That gives them their own specific tokens during training. So they're going to, pre-train this model, or take a pre-trained model. In this case, they're taking Google's Gemma, I think a 2 billion parameter version of that model, and they're going to give it a little extra training, a little bit of fine tuning. They're going to train it on a data set in which tools are given, again, their own tokens. So when we talk about tokens, right, we're talking about usually parts of words or whole words that are essentially part of the dictionary, the fundamental list of foundational entities that this model is able to reason about, right? So it's syllables or characters sometimes, as it was in the old days, and or whole words, whatever that may be. So they're actually going to, instead of having the model like spell out the function name, for example, that it might have to call, they're going to assign the whole function one token. So it is one thing, one idea that the model has to hold in its head to call on. And that gives it a level of concreteness that makes it much more reliable. Like the model no longer has to solve many different problems at the same time to call a function properly. It just has to like reach for the right token instead of spelling out whatever the function is or reasoning about what its sort of characters might look like. And so, they end up integrating a two-stage process that is usually used by an agent to call a function. So this is usually one, pick the right tool, right? Usually using a classifier. And then second, generate the right parameters to call that function, to use that tool. And normally that's treated as two different steps. The first one, you'll use like a classifier to solve for that. And then the second one, maybe you'll use like a language model. They're integrating those two into one step thanks to this tokenized function calling technique. They're able to generate the parameters for the function call at the same time, and allows the problem to be solved in a way that sort of leverages advantages that only become apparent if you can hold the whole problem in your head at once. So I was thinking about how to explain this a little bit. One way to think about this is like, sometimes when you're picking the right tool for a job, you want to think a little bit ahead about like how you might creatively use that tool. And only if you think both of the tool and how you want to use it, do you fully have the kind of the option priced out, right? So like a hammer may not seem like the right tool for the job, but if you think about a clever way to use it, you might be like, oh, that actually is better than a pair of scissors or whatever. So same idea applies to these APIs. If you're thinking both of which API you're going to use, which function you're going to call, and the arguments you're going to feed to it, you might kind of spot opportunities to use other functions in unorthodox ways. So this leads to performance improvements that are quite noteworthy. There's also just like much better inference time for these systems. They're able to just like get a lot more throughput with Octopus than with, say, Llama 7 billion or GPT 3.5 using retrieval augmented generation. So pretty impressive result. And another bit of it's a simple tweak, right? It's just this idea of like, let's, instead of spelling out the function names, let's give them their own token. But if you're interested in doing AI agents, this may just be a quick way to avoid small fraction of the errors that otherwise might compound over the course of a complex interaction and cause your agent not to work.
Next up, bigger is not always better, scaling properties of latent diffusion models. So this is looking at the scaling of particularly image generation, which is nowadays usually done with latent diffusion models. And there's various results in this paper regarding scaling. The key one they highlight is that, interestingly, if you sample images with the same cost, so if you take kind of the same number of steps when accounting for the model size, the actual image quality output could be better from the smaller models. So if you don't expend more compute when you use the larger model, the smaller models apparently are kind of potentially more efficient in their computation. And the paper highlights some potential ramifications in terms of being able to improve efficiency when, for instance, distilling larger models into smaller ones.
Yeah, full disclosure, I have not read this paper actually. I'm really curious about it just because, scaling is so central
Scaling,
to
of course.
Yeah, that's it. So no, curious to check it out. And how specific it may or may not be to LDMs. Like, I don't know if this is dependent on that architecture, but yeah, something I'll definitely be diving into.
Yeah, it's a very empirical study. They have, a bunch of image outputs. They do, of course, have a quantitative metric for image quality. So it's compared to something like language models. I think in latent diffusion models and image generation, we haven't had as much research on scaling.
Mm-hmm.
So this has some interesting insights, and of course, they show that as you scale, you get better outputs. Similar to language models. And moving on to the last paper, which we'll try to get through quick, although we might wind up discussing it for a little while. The paper is Many-Shot Jailbreaking, coming from Anthropic with a few collaborators such as University of Toronto, Vector Institute, Stanford, Harvard. And the short version is they present a new kind of way to jailbreak to make language models do things that you don't want them to do. So, for instance, language models are meant to not answer questions like, how do I make meth? But there are many ways to kind of get around it and fool them into answering questions like that. And this many-shot jailbreaking approach is pretty straightforward. Basically, you just start by giving it a lot of examples of it doing the wrong thing in the prompt. So start by saying, how do I hijack a car? Then you yourself provide the answer. How do I steal someone's identity? Provide the answer. Eventually, after a lot of these, you insert the actual question you want the language model to answer. And because it has in-context learning, because it picks up on the pattern of the prompt, it will go ahead and be jailbroken and respond. So they highlight this potential way to jailbreak, especially for larger models that are better at in-context learning, and they look into mitigation. Training is, somewhat effective, but really it's hard to mitigate against because it is a factor of in-context learning. So, and then you may need to do something a little more involved, like classifying or trying to catch the prompt rather than just tuning the model.
Yeah, I really like this paper, partly because I think what it reminds us of is this complex dance and interdependency between capabilities of an AI system and its alignment, right? Like, this really does show us, yeah, like, it's just learning in context. Like, that's what it's supposed to do. You try to train it to refuse these dangerous prompts, but then you give it enough examples of it not refusing those dangerous prompts, and then it'll just like start to not refuse them again. It's just learning in context, as you said. That's just capability, and yet it manifests as a misalignment. And so this tells us that there's something kind of deeply wrong with the way that we're training these models. If we actually want them to behave in the way that we do, more training, as you said, is not the solution, right? What ends up happening is, and they talk about this in the paper, you could take the approach to say, okay, well, you know what? I'm just going to train it by showing it a long chain, and they do like 256 examples of dangerous requests and then the execution on those dangerous requests. And then on the next one, put a rejection, have it say, no, even at that, I'm not going to give you what you're looking for. So essentially, like, you can try to say, okay, well, it's not resilient to maybe 3 shots of jailbreaking. Like if I give it 3 examples of it responding to a query that it shouldn't, maybe it gives you the answer then. You're like, fine, okay, so I'm going to train it by giving it 3 of those things, and then the 4th, make it a refusal. But what ends up happening is you just keep pushing that down. Like, you just have to go further and further and further. And sure, you might do this with 256 examples, but then on the 257th or the 300th or whatever, it's, just give it enough in context examples, and eventually it will pick up on the pattern and fold. And that's really where they get into this idea that more training, more fine-tuning is maybe not the answer here. That seemed not to work super well. And they did have more success with methods that involved classification and modification of the prompt before it was passed to the model. So in a way, you can interpret this as sort of a patch, right? You're not actually solving the problem with the model. You're actually bringing in auxiliary models to review the inputs. And if you accidentally let one of those inputs through, the same problem will kind of present itself again. So yeah, I thought this was fascinating for what it tells us again about that connection between capabilities. Like, don't get mad at your model if it picks up on the freaking pattern that you put in the prompt. That's what it's supposed to do. But like, we don't really know how to solve for that. And anyway, sorry. And last kind of philosophical note there is, we've also seen how there's a potential sort of like equivalence in a sense, or exchange rate between the compute you use during fine tuning and the compute you use at inference. Given enough of a long prompt, enough context, the impact of that context may actually be fundamentally the same as the impact of fine-tuning. So it is almost as if people are fine-tuning out the refusal to respond to certain queries. That is one interpretation of what's actually going on here. And if that is true, again, this is a pretty fundamental thing. If we want our prompts to not affect the behavior of the underlying model, well, that's going to prevent the model from displaying any useful capabilities. So anyway, fascinating paper. Big ups to Anthropic for another great piece of work.
And moving on to policy and safety, the first story is Schiff unveils AI training transparency measure. This is about Representative Adam Schiff from California, and this is brand new legislation called the Generative AI Copyright Disclosure Act, which would require organizations to disclose whether they used copyrighted data. So they would need to submit a notice to the Register of Copyrights with a detailed summary of any copyrighted works and the URL for any publicly available material. Apparently, the bill would require the notice to be filed no later than 30 days after the AI system is available to the public for use. And it would also apply retroactively to AI systems already publicly available. So that seems like a pretty spicy bill that is being proposed here that would require AI companies to disclose where they use copyrighted data, which for now is not at all the case. And the Register of Copyrights would publish an online database available to the public with all the notices, so we would know what copyrighted people use. So hard to say if this will pass, I guess, but certainly seems exciting to consider what would happen if it does.
Yeah, well, it's one of those careful what you wish for things, right? Because we were talking earlier about how courts come down on this whole copyright thing, and well, this is, I guess, one step in that direction. Interesting to note that this does not necessarily say you cannot use copyrighted data, right? This is saying you just have to let us know, which is sort of, let's say, a step before that. So in that sense, yes, spicy bill in the sense that it is asking for something. But, I think realistically, given the scope of capabilities we've seen, we literally just opened this episode with like an AI generated, totally plausible sounding, jazzy intro song that, might, from a capability that could automate away a crap ton of jobs. Sora, like, think about all the changes we have before us, and we're almost certainly underestimating the magnitude of the changes that are going to come. There are a lot of spicy bills that ought to come forward if we're going to sort of meet the challenge of these major changes that are going to unfold to our society. So in that sense, stuff like this, I think it ought to be considered in the context of that broader technological change. I think superficially, this seems to make sense. At least have people disclose the training data that they're using, or at least if that training data uses copyrighted material. I don't see anything here that specifically says you have to tell us about what your training data is, which itself would be a very difficult thing to ask for, right? Companies are not going to be in a hurry to reveal what the training data are.
Well, it seems a little ambiguous. It says detailed summary of any copyrighted works used and the URL for any publicly available material, at least in the article. So it seems like maybe you would want to be able to be a little specific.
Yeah, okay. I was interpreting that as meaning, a detailed summary of any copyrighted works used. So like if you're going to use the copy, essentially the tax here is, yeah, look, you're using copyrighted material. You have now abdicated your right to do that in secret.
That's right.
You got to be open about that. But to the extent that you're using openly available stuff that is non-copyrighted, then like totally kosher,
Yeah, that's true. Yeah.
Yeah, so like it's a bit of a battle, but you're right? Like this is, I don't know how you square the circle around this stuff while respecting the copyrights of companies, while even just respecting the company's ability to litigate. Like we right now are in a situation where the New York Times or whoever it is has to find a clever way to demonstrate that some company has trained on their data, and that itself, it's unclear if that's actually a reasonable situation to put a publication like the Wall Street Journal or the New York Times or Fox News or whatever. Like, should they really have to do the heavy lifting to prove that you did this, let alone having to do the legal battle to establish whether or not that is okay in the first place? So I think it's interesting. It's also like, I don't know, again, not a lawyer, but for people to even know that they ought to be considered as part of a class action lawsuit, if that happens in this context, like I would need to know that in fact my copyright has been infringed upon, or at least that my copyrighted material has been used, to even figure out if I should join the class. Again, super not a lawyer, but there is a sense in which a new kind of information could be made available to the public that would be helpful for people to defend their rights to the material they make. Haven't read the bill, so I don't know if this is overall a good idea or not, but just the high level picture, it feels like the kind of debate that should be happening. At least that's how it strikes me.
Next story, kind of a spicy, dramatic one that is going to be exciting. The headline is Linwei Ding was a Google software engineer. He was also a prolific thief of trade secrets, say prosecutor. So apparently this person is facing federal felony charges for allegedly stealing 500 files containing Google's AI secrets and marketing himself as an AI expert to Chinese companies. And this, of course, plays into a larger question or I guess topic of copyright theft and intellectual property. There is a bit of a history of Chinese companies going after intellectual property of the US for decades now, especially when it comes to tech. So this plays into that. And yeah, it's I guess if you're Google, you have to be careful now for that sort of thing, for your trade secrets.
Yeah, I think a lot of these AI companies really are going to have to mature quickly on this stuff. The reality is that they've gone from iterating on prototypes for the last decade to all of a sudden they're building artifacts of profound national security importance. And that didn't happen sort of in a way that would have been transparent to them. People are unclear about how important these things are from a national security standpoint, but as far as China's concerned, they absolutely seem to be. And there are indications that China's trying to exfiltrate models and things like that. So this is something to be concerned about. The backstory here is kind of interesting. Linwei Ding himself spent months, it said, at a time in China, despite living in the US and supposedly being full-time as a software engineer in Google San Francisco area offices. And he apparently had people like doing the equivalent of putting in like punch cards for him so that it would seem like he was actually at work while actually being overseas doing whatever else. It said he stole 500 files containing, as they put it, some of Google's most important AI secrets. I've tried to dig this up. I seem to remember a tweet from a Googler saying, hey, I want to clear the air on this. Linwei Ding was actually, I don't know, sharing some like internal stuff about, I don't know, how we're thinking about, I don't know if it was more on the ethics side or whatever, trying to get input from Chinese companies for some reason. Anyway, it seems, at least based on this article, the claim seems to be that is not the extent of what was stolen. There seems to be some like important technical secret sauce there. And so his home was searched by the FBI. And it was apparently just days before he was about to board a one-way flight to China, where he was arrested at that point in March, and their federal felony charges. So yeah, this is, strengthens the argument that certainly I have made, that a lot of people in the space have been making, that progress at frontier labs, to the extent that it is not secured, is Chinese progress. We've heard this from folks at Top AI Labs when we speak to them, where they're talking about the security situation there. Often comes up there's a running joke, as we said in our report, actually, that one of these labs is like China's top AI lab because probably their stuff is being stolen all the time. That's what we were hearing. Not always a great sign. This certainly doesn't help in terms of that narrative. So yeah, we'll have to see what the next moves are, what the evidence is that's surfaced. Oh yeah, sorry. There's one last thing I want to highlight here. A bit of a quote in the article. It says the indictment said Google had robust network security, including a system designed to monitor large outflows of data, but Ding circumvented that by allegedly copying data from Google source files into the Apple Notes application on his Google-issued MacBook laptop, converting the Apple Notes into PDF files and uploading them from the Google network into a separate account. So like this is not rocket surgery, right? Like this is just like what you would do to get away from using Google products, Google networks, and so on, fairly intuitive. And there apparently was not a measure put in place to prevent this from happening. Not the kind of thing you would expect from nuclear security, chemical, like biological or chemical weapons research facilities, things like that, to the extent that we think these things may be on a trajectory like that, which Google certainly seems to think publicly. It suggests the need for these sorts of things. These are not bad actors. This is a very challenging and thorny problem, but certainly means that there's a lot of growing up that needs to happen internal to Google, and I'm sure a lot of the frontier labs, to deal with these kinds of risks.
That's right. And in the article, they go a little bit into what was seemingly stolen. They have a professor comment on it, and apparently the technology secrets dealt with the building blocks of Google's supercomputer data centers and had a mix of information about hardware and software, including potentially chips, which of course would be very dramatic. So still early on. It's not clear if the data or secrets were actually distributed. It's not clear if the person will be in jail for a long time. Apparently, he could face up to 10 years in prison. So, yeah, definitely a dramatic story and highlighting what a big deal AI is now that this sort of stuff happens.
All right, moving on to our lightning round, we have responsible reporting for frontier AI development. This is an AI policy paper coming out of a research collaboration that includes folks from the University of Toronto, the Vector Institute, which are kind of linked together, Oxford, and the Center for Security and Emerging Technology, also Google DeepMind, MIT. It's a really, really broad group. Some very, very respectable researchers there. Leonard Heim, I see there on the list of names, Gillian Hadfield, Marcus Anderlich. So really, yeah, very knowledgeable folks looking at what are the reporting requirements that we ought to set up when we think about advanced AI development with increasing levels of risk, trying to figure out how to get information from AI developers in a way that balances the need for intellectual property protection, but also this need to inform policy and policymakers and regulators so they understand what's going on and have the full risk picture. So they have this great table where they summarize the kind of data that they think ought to be reported, the category of people who should be receiving it, and there's a lot of finessing and trying to figure out what the borders and boundaries should be between sort of like who should be able to have access to what. Obviously, a lot of sensitive information. One of the things that that they say here is that sharing the models themselves. I thought this was interesting. They don't actually propose that. So they're proposing reporting on a wide variety of different things, risk assessments, ideas about anticipated applications, current applications, that sort of thing. What they don't propose is actually sharing the models. Yet, I find this interesting. I'd be curious to hear why specifically they went in that direction. Obviously, very high IP bar, but our own research suggests that may be something that that you actually ultimately do need. This may be a stepping stone, but as they put it themselves, aviation regulators are authorized to conduct sweeping investigations of new aircraft technologies, while financial regulators have privileged access to cutting-edge financial products and services in order to assess their anticipated impact on consumers and markets. The fully analogous case here, I would think, would be to allow regulators to directly red team models themselves, and maybe even hand over model weights temporarily in a secure setting. Obviously, very different risk profile associated with that, a lot of IP risk, but I'm always interested in where people draw that line, and I'm sure they'll have very interesting reasons for that. But just wanted to flag that as kind of an interesting interesting question. And the last piece I'll mention here is they look at a mix of like voluntary measures and regulatory measures. So what would it take if it's just voluntary? What do you think you could get these labs to agree to just on a voluntary basis? And they look at things like, okay, well, disclose information only to developers, only to government. Don't share it with other developers, obviously for IP reasons. This was interesting. Have anonymized reporting to avoid reputational risks. Right? If you have a frontier lab that comes out and says, oh shit, our thing can like help you, I don't know, design bioweapons or something, there's reputational risk that is born then by that entity. And they may not be keen to just take that on, right? If it's a purely voluntary thing. So, maybe you guarantee an anonymized reporting and just say, hey, a developer has flagged this. And then on the regulatory side, anyway, if you can have this be formalized in regulation, what happens? They look at what consequences to bring in if labs don't report, and anyway, safe harbor measures if they do report dangerous capabilities. So like you can't basically be more liable or have more legal exposure for reporting these things. You want to encourage that to actually happen. Anyway, I thought it was a really interesting paper. If you're into AI policy and the catastrophic risk piece, I thought it was nicely thought out, well organized, and an all around fun read.
Yeah, not much to add to that. I think it's a good summary. So, next story is U.S. government wants to talk to tech companies about AI electricity demands and eyes nuclear fusion and fission. So, yeah, apparently the Biden administration is seeking to expedite discussion with tech companies about their lowering electricity demands for AI data centers. The Energy Secretary Jennifer Granholm has highlighted the increasing needs for this, saying that AI is not the issue, but that regardless, there needs to be something. And apparently the Department of Energy is considering the idea of placing, quote, small nuclear plants near tech companies' large data centers. Kind of, we've seen before some considerations like this, like Microsoft has already invested in nuclear fusion.
Yeah.
So definitely more, still a very tentative kind of conceptual thing, but an interesting thing to note that potentially this could be something that ends up being needed for AI is straight up nuclear power.
Absolutely. And the big challenge, right, is renewables offer you such high variability in terms of power output. Is the wind blowing? Is the sun out? That sort of thing. Whereas the requirements of large training runs are very high baseload power, right? They just need like they eat a constant amount of energy over whatever the period the training run is going on for. So that means that you need a very, very powerful and consistent source of power. And nuclear is exactly that. And that's part of the reason why these big data center infrastructure buildouts are often being paired with concurrent buildouts of nuclear energy and other things. Right now, power, like baseload power, is the key bottleneck in the West. It's not in China, right? China has tons of power infrastructure. They're kind of looking at the opposite problem where they're bottlenecked by chips because of the export controls that the US and other countries have imposed. But in the US, the issue absolutely is energy. And that's why Sam A is so focused on fusion. It's why he's invested in Helion energy. It's why he's pushing so hard for all these things. But always interesting that like the bottlenecks don't have to be the same in different geographies, and ultimately the bottleneck is the only thing that's preventing you from moving on to that next level. It's the main thing you want to focus on if you want to scale more, and in this case energy, just so important.
Next up, onto a legal thing. Washington state judge blocks use of AI enhanced video as evidence in possible first of its kind ruling. So this related to a man accused of shooting outside a Seattle area bar in 2021, and the lawyers sought to introduce a cell phone video enhanced by machine learning software. And the prosecution argued that the enhanced video predicted images rather than accurately reflecting the original video and called it inaccurate, misleading, and unreliable. Therefore, the judge blocked the use of it, and potentially this could have ramifications for being able to use machine learning to enhance the clarity of videos or photographs in cases in the future.
Yeah, I'm always I'm obviously not a lawyer and don't know much about this stuff, but I'm a bit of a legal nerd in terms of these precedent-setting cases. And I thought the backstory here was kind of interesting. So you've got a guy who's accused of having opened fire outside a bar. This is in Seattle back in 2021. He killed 3 people, wounded 2. And he wanted, or his lawyers wanted, to introduce cell phone video evidence that, was enhanced by AI software. This whole confrontation, by the way, was captured on the video, right? So they have the original video, but they're trying to enhance it in a way that, I'm sure the defendant would say provides further context, but that the prosecution is saying it's made up context, it's generative AI. And so anyway, apparently the defendant turned to a guy who previously had no experience handling criminal cases, but had a background in creative video production. And so he used this tool by Topaz Labs, who I'd never heard of before. They say that they help people, like creative professionals, supercharge video. That's sort of the generative AI play that they're doing. And interestingly, Topaz Labs itself said that, basically like, don't use our stuff for this shit. Don't do it. Don't do it. Don't do it. And what they did, the defendants, is they said, what is that? Do it. Do it. Definitely do it. Yes. And they went ahead and made that case. And they said, like, I know Topaz Labs is saying don't do it, and you shouldn't rely on their stuff, but you should rely on it. You should, because we say so. And so the prosecutor's office apparently is making the case that, look, hey, these enhanced images are, as they put it, inaccurate, misleading, and unreliable. So ultimately, that's where things stand. The judge came out and basically said, look, this technology is novel, so that's always an issue, right? In when you're setting legal precedent, and it relies on, quote, opaque methods to represent what the AI model thinks should be shown. And as a result, kind of threw this out as sort of black box woo stuff. But it's interesting. This is a really interesting question. How do you assess the truth value of generative AI stuff, right? If it's just like a Bayesian model, we're all trying to do this Bayesian inference. That's what a legal proceeding kind of is. We're all trying to decide, like, does this meet our, beyond a reasonable doubt threshold or balance of probabilities threshold, whatever the case may be. But like, arguably a model is kind of trying to do the same thing in a technical way. Still, as my dad would often say, there's a reason that the threshold of probability in a criminal proceeding is framed as beyond a reasonable doubt, and that they don't just say, like, you got to be more than 90% sure or 99% sure. There's deliberate ambiguity there. And so you can't necessarily just have an AI system like math out what the odds are of a certain thing. I guess that would be contrary to the spirit of this. I'm done nerding out. I thought this was a really interesting story. And don't go shoot people and try to use generative AI to cover your tracks.
Yeah, now we know. Don't do that.
Now we know.
And one last story, Trudeau announces $2.4 billion for AI-related investments. This is, of course, the Canadian government, and the $2.4 billion, most of it will go towards providing access to computing capabilities and technical infrastructure, $2 billion, and then another $200 million will be dedicated to promoting the adoption of AI in sectors like agriculture, healthcare, and clean technology. And then there are some other details as to where the rest of that $2.4 billion will go. There's also Bill C-227 involved here, which is apparently the first federal legislation specifically aimed at AI, and will update privacy laws and introduce new applications for high-impact systems. So, Canada, we don't, I guess, often talk about it, but there are some, pretty significant research institutes for sure out there, and the government is seeming to want to push that forward.
Yeah, Bill C-27 in the AI and Data Act, which is contained therein, is kind of like Canada's attempt to do something like the EU AI Act, but it does have a bit more bite in some interesting ways. So anyway, it's a whole rabbit hole. I think we might have talked about it previously on the podcast. The big thing to me was actually a small thing buried in this $2.4 billion, there is a plan to launch a $50 million AI Safety Institute to protect against what it calls, quotes, advanced or nefarious AI systems. And you know who was at the announcement of this thing was Yoshua Bengio. So I suspect the government's going to look to tap Yoshua to maybe oversee this. You know, he certainly has concerns around loss of control and weaponization of these systems. He's emerged as sort of like de facto consensus expert guy internationally for, like Rishi Sunak tapped him to help lead their sort of build consensus operations internationally on AI risk. And it's interesting to see him implicitly endorse this with his presence there. So kind of cool. $50 million for an AI Safety Institute. Not a ton of money, but still it means Canada joins the US and UK in having its own AI Safety Institute, if in fact this does go forward. So I think that's kind of noteworthy. You know, it was part of the vision that I think it was Gina Raimondo, the Department of Commerce, said, you know, we want to have this network of AI Safety Institutes around the world. And this certainly would be consistent with that vision.
Just a couple stories left. One in synthetic media and art that is worth highlighting. We have the story that Billie Eilish, Pearl Jam, Nicki Minaj, and many others, 200 artists, called for responsible AI music practices. So they signed an open letter issued by the nonprofit Artists' Right Alliance that called for organizations to stop using AI in ways that infringe and devalue the rights of human artists. So in particular, they have concern on AI models trained on unlicensed music, which they say is unfair. So yeah, pretty significant statement there from very famous and notable musicians coming just before what we started with, Udio, right, and Suno. So a bit of a awkward timing there in a sense, but certainly seems like what happened with image generation,
yes,
like 2 years ago, is now happening with music generation. And it'd be interesting to see, because in music there's a bit more organization, a bit more, money and fame in general, how that plays out compared to what happened with image generation.
Yeah, it's also just like this last bit where they're asking folks not to develop or deploy AI music generation technology that undermines or replaces human artistry or denies fair compensation for artists' work. Like, I don't see how you can ever do that and have these things be useful at all. So like, this amounts to, I think, a plea for these things just not to be used, or certainly not to be open source. That's guaranteed, right? There's no way that you can open source models and be consistent with this. But then, yeah, more generally, even for paid things, it's like, how would I don't even know how I would do this without implicitly taking away an opportunity for an artist. So look, it's a thorny issue, and everybody's trying to solve these problems. We had to deal with the WMD version of this with our action plan, and this is the music industry's version of this. How do you square the circle? Hey, wish I had the answers in the music industry. That this is pretty tough.
Mm-hmm. And do want to highlight one fun story before we close out. This one is OpenAI's Sora just made its first music video, and it's a psychedelic trip. So there's been quite a few examples of Sora being released in past weeks. OpenAI has started shopping around, and we saw some fun short films. This one is a music video to the song World Weight by August Camp, created entirely by Sora, and it's just a series of short clips with various kind of surreal elements and environments. There's no narrative to it. There's just imagery accompanying this kind of ethereal music. So in a sense, they fit well together in sort of a music video. You could see it working in this sense. And it's I think, to me, an interesting example of a useful application of video generation where you could use it especially for b-roll and for things like music videos with kind of a loose, no narrative, no sort of overarching visual content, but a mixture of clips that AI can then generate for you. And, it is worth highlighting that, now you have a music video with a bunch of very cool imagery that would have been much harder to develop otherwise without Sora.
Yeah, absolutely. And I think you're absolutely right on the B-roll piece. I'm thinking about the handful of times I've had to use B-roll or, go to Pexels or what, whatever the websites are now. And the level of specificity that you're often trying to get for the B-roll, that ends up being a big blocker, right? You're trying to find somebody using their right hand to grab a drone and do such and such. And this is exactly the sort of thing that allows you to bridge that gap, right? It's all sort of, it's not out of distribution. It's very much, it's been trained on a bunch of different things, and you often want to just combine those elements. The combinatorics is the big problem for sort of free to download B-roll footage websites. So yeah, I think this is a big challenge for those platforms. How do you, what's the response? Do you have your own generative video thing, and then is that a race to the bottom? I don't know, but new era for that.
And with that, we are done with this latest episode of Last Week in AI. Once again, you can find the articles we discussed here today at lastweekin.ai. You can also reach out and give us comments or feedback at contact@lastweekinai or hello@gladstone.ai. Those are in the episode description. As always, we appreciate you listening and sharing and rating. And do be sure more than anything to keep tuning in and listening.